So what we're going to talk about today is inverse trig functions. So we know that for a regular trig function, when I write trig, I just am using it as a stand-in for sine, cosine, or tangent. I do trig of an angle, and I get back, stop talking please, like a ratio of side lengths of a right triangle. Or as we discussed in a previous chapter, it could also be related to the position of the terminal side of an angle on the unit circle. So if I take sine, cosine, or tangent of an angle, I get back, something like a ratio of side lengths, or maybe it's the, a position of the terminal side of an angle on the unit circle. And by position, I mean, it's some way related to the coordinate, the x or y coordinate. What are you asking, Kendall? So what the sine, cosine, and tangent are doing is basically taking an angle and translating it into turning it into a real number. So our inverse is going to go the opposite way. It's going to take a ratio of side lengths or some kind of coordinate or position from the unit circle and translate it back into an angle. So our trig does this, and the way we'll write our inverse trig is we'll put a little -1 in the exponent. So for example, if I take sine inverse of 1/2, what this is going to do is if I go back and I think about my unit circle, sine is the y coordinate for my unit circle. So sine of 1/2 corresponds to the angle 30 degrees. So if I take sine inverse of 1/2, I'm going to get back 30 degrees. Yes, Lexi? Uh-huh. Sure. Yeah. So there's a 1/2 right here. So cosine inverse of 1/2 would be 60 degrees. Mm-hmm. Yep. Remember that tangent is y over x. Yep, which would turn into 1 over root 3 when you did that division. So one of the things that we'll notice, I guess I should have kept the unit circle up. One of the things you might notice on the unit circle, we had sine inverse is equal to 1/2, or sine inverse of 1/2 is equal to 30 degrees. But this is not the only place on the unit circle where sine is 1/2, right? It also is over here. Now, can I have... can something be a function if I have one input, like 1/2, but I get 2 outputs? No, right? That violates the definition of a function. So if we think back to the graph of sine, the graph of sine would look like this, right? If you think back to our Algebra 3-4 class, when I take an inverse of something, what I do is I swap the x and y coordinates, right? So if I do that, I'd end up with a function that looks like this, or my resulting inverse would look like this, and this is no longer a function. So we're going to have to do something to kind of make sure that these inverses are functions, because we can't program something into a calculator that isn't really a function, right? We need to just get one output. The calculator's not going to give you, in this case, like infinitely many outputs. That's going to break the programming. So the trick that we're going to do is we're going to restrict the domain for sine. So we're going to cut off here and here and only use this part in the middle. So we're going to restrict the domain of sine to be negative pi over 2 to positive pi over 2. When we do that, the range for sine still is negative 1 to positive 1. So if I want to write sine inverse now, sine inverse is now going to be just be this part. It's getting a little messy color-wise. But what's going to happen here? Well, the domain for sine inverse is the same as the range for sine. And the domain for sine is going to be the range for sine inverse. And this is how your calculator is programmed. So your calculator is only going to give you values of sine from negative pi over 2 to positive pi over 2. Or, I'm sorry, values of sine inverse. So what is that really saying when we say a range from negative pi over 2 to positive pi over 2? We're really meaning we're only going to get answers in quadrant 4 and quadrant 1 of my unit circle. So if I go back and I think about sine inverse of a half, when my calculator computes that, the values of sine that it's considering are only the values here in quadrants 1 and 4. So the only place that sine is equal to positive a half is here at 30 degrees. It's not going to consider the situation where sine is a half out here at 150 degrees. This part is not, the calculator is not going to be able to find those values because of the way it's programmed. I'm not saying that. I'm saying the calculator is not going to give you an answer from that side. Now those are still real answers. Like sine inverse of a half, 150 degrees is a perfectly valid answer. The calculator is not going to report that answer back to you. Hannah. That's okay.
So the reason you can't see it in quadrant 2 and 3, are you talking about when you graph it?
I'm talking about when we use our calculator to calculate sine inverse. It's not going to report back an answer from quadrants 2 or 3.
Okay, you mean report back in numbers or?
So if let's pull up the calculator and just kind of show you what I mean. Okay, make sure I'm in degree mode. Okay. So if I do sine inverse of 1/2, it's going to give me 30 degrees. It's never going to give me 150 degrees. But I know that sine of 150 is equal to 1/2. So that 150 is an answer to sine inverse of 1/2 equals some angle measure. That is an angle measure that does give you sine of 1/2. The calculator won't give that to you because of the way that we had to program the calculator, because it can't give you back infinitely many answers, even though there are infinitely many answers to that question. Is that okay? You're welcome. Is everybody else okay with that idea? So one of the trickiest parts of dealing with this is making sure that we can take the answer that our calculator's given us and actually use that to build out the answer that we're looking for. Because maybe I'm not interested in my answer in the third quadrant or the first quadrant or whatever quadrant that my answer can report in. I might be interested in a different answer. So one of the tricky things we're going to have to deal with is figuring out how to find a different answer. Because there's infinitely many answers when we do sine inverse of whatever. It's the question of which one of those infinitely many ones do we want. The calculator's only going to give us one of them, but we can use that one to find any one that we might be looking for. And that becomes kind of the trickiest part of this section. So let's just do a little bit of an information dump after I've kind of set up what's going on here. So we said that sine inverse is only going to give you values between negative pi over 2 and positive pi over 2. Cosine inverse is only going to give us answers between 0 and pi. And then tangent inverse is only going to give us answers from negative pi over 2 to positive pi over 2. Notice that I used parentheses for tangent and not brackets. What is the difference between when I use parentheses and brackets in these situations? Yeah, good. So the bracket means that we're including these values in the set. Parentheses means these values are not included in the set. Why can't we include negative pi over 2 and positive pi over 2 in this set when we're dealing with tangent inverse? It's not because it would be sine inverse. What is tangent of, say, negative pi over 2 equal to? Let's try that in our calculator. Right? So if I do tangent of negative pi over 2, I do get undefined. And that's why, oops, I'm in degree mode. Negative pi over 2 is negative 90, so I'll write it in degrees. I get undefined, right? I get the error here. So that's why we have to have a parenthesis there, because you can't do tangent inverse of undefined. That doesn't make sense. You can't do anything to an undefined. That's why we have to put the parenthesis there, rather than a bracket. Sine has no asymptotes. It's defined everywhere. Tangent has those asymptotes, so we have to be a little bit careful there. Okay. So let's say I want sine inverse of negative 1/2 for theta between 180 and 270. This is equivalent to asking for it between pi and 3 pi over 2. I'll try to write these things in both degrees and radians just to help. I know some of us are still catching up with like seeing the radians and knowing exactly what that means. So I'll try to write the degrees and radians here together. just so that nobody's confused. So if I want to do this without using my calculator, I'm going to look at my unit circle. Sine inverse, or sine is which coordinate on my unit circle? It's the y's, right? So I'm going to look at the places where, I'm going to look at all the y coordinates and look for the places where I get a negative 1/2. So that's 7 pi over 6, or 210. And then 11 pi over 6, or 330. Everybody's okay with how I pulled those from the unit circle? Now I need to check to see which one of those answers meets this criteria. Which one of them falls in that given criteria? 7 pi over 6 or 210, depending on whether you're looking at it as degree or a radian question. Everybody okay with that? So I just went to the unit circle and looked at the y coordinates. And what I'm looking for is places where I get negative 1/2. And then I just wrote down the angle measure that corresponded to that position. So 7 pi over 6 or 210. And then I just kept going, and I found another negative 1/2. So I wrote down also 11 pi over 6 and 330. So the calculator will not report back to you the other one. That doesn't mean it's not an answer to sine inverse of negative 1/2. Exactly. Because the calculator is not going to give you any answer you want, or even necessarily the answer you're looking for. It's only going to give you answers in those two quadrants. Now there's lots of answers, right? Is everybody okay with that idea? Okay. Let's do another one. If I want to do cosine inverse of 0.56. Is this a unit circle value, 0.56? No. So I can't use my unit circle to get the values. What should I use? My calculator. So I'm just going to do cosine inverse of 0.56. And now before I report this as an answer, oh, maybe I should be a little bit more specific here. So let's say we want this. Anderson? So that's a good question. The answer is going to be depending on whether this is listed as degrees or listed as radians. So depending whether it's specified your answer needs to be between radian to radian, your calculator should be in radian mode. If it's listed between degree and degree, it should be in degree mode. Mine is in degree mode right now because I feel like for the most part you guys do better when I do things in degrees first than starting with radians. I think most of us are more comfortable kind of living in that world. So that's what I've done right here. Good question, though. All right. So I noticed right away that 55.9 is not between 270 and 360. So this isn't actually the answer I want, although it's a correct answer for cosine inverse of 56. So what I'm going to do is I'm going to draw myself a picture and try to figure out what is the actual answer that I'm looking for here. So 55.9 degrees is like this angle right here. Right? Remember when we draw angles, we start on the positive x-axis and we rotate counterclockwise. So 55.9 is about there. Now I'm going to go back and remember about all silly turtles crawl. Remember what these letters told us is what of our trig values is positive in that quadrant. We're looking for another location where cosine is positive. That needs to be in the fourth quadrant. Everybody agree with that? So my other answer is going to be there. So the angle I'm interested in is that one. That's going to be the answer to the question that I've been asked. Is everybody okay with that? That huge whole angle. So to figure that out, I'm going to have 90 plus 90 plus 90 plus whatever that part is right there. Everybody okay with that? Okay. So to figure out that part, we're going to take advantage of a special property. So the angle that is formed relative to the x-axis here is the same angle that's formed relative to the x-axis here. What that tells me is this part is also 55.9 degrees. So our question mark here is going to be the complement of 55.9, which would be, what, 33.1? Or 34.1? Can do arithmetic. So my answer then is going to be 90 plus 90 plus 90 plus 34.1. I don't know why I need to use a calculator to do that. So I should have 304.1. And if I can check that by just doing cosine of 304.1, which is almost exactly 0.56. Why isn't it exactly 0.56? Because I rounded the 55.9, right? If I kept all the decimals there all the way through, I would get exactly 0.56. Just to illustrate that, if I did 360 minus this guy, and then do cosine of that. Oh, I guess it's still round. Left me with a little bit of dangler there. It's a little closer, though, than the other one was. Yeah. So I just showed you the reason I took cosine of the 304 at the end was just to show you that you can check your answer, right? Let's try another. Oops. Say we want to do tangent inverse of 0. Is 0 a unit circle value? Yes. So if I go and I look at my, if I go and I think about this, remember that tangent is y over x. So I'm looking for a place where the y-coordinate is 0, and the x-coordinate can be anything it wants other than 0, and it's still going to be fine, right? Everybody's okay with that? So let's go to our unit circle and take a look for a place where the y-coordinate is 0. So I see it here. Here. And those are the only two places, right? At 0 and at 180. So depending if we were talking in radians or degrees, I wrote both sets of answers. So if I wanted to say then, if I wanted my answer between, say, pi over 2 and 3 pi over 2, which answer should I give there? Pi, because pi is definitely between 1/2 and 1.5 pi's, right? Everybody okay with that idea? Let's do another. Hannah? So this piece at the end is going to tell you what mode your calculator should be in. That's part of the given problem, yeah. So I see these things and I see the pi's in there. I know that we're talking in radians. Should be giving a radian answer. So I would use my calculator in radian mode in that case. Okay with that idea? Hold up. Well, no, the part at the end that I'm still writing in is going to tell us what mode we want. So this would tell us radian mode, right? So that's first thing I'll do is change my calculator to radian mode, because negative 6.10, definitely not a unit circle value, right? So I've got my calculator in radian mode now. And I'm going to go ahead and calculate tan inverse of negative 6.10. So let's go ahead and draw where this angle is. So negative means I'm going to be going in the clockwise direction, reverse of usual. And then how far into the quadrant is 1.4? So if this is 0, this would be like negative pi over 2, right? If we're going in the negative if we're going clockwise. If I type that into my calculator, negative pi over 2 is about 1.57. So we are going to be in this quadrant down here somewhere. Everybody okay with that? But the answer that I'm looking for needs to be a positive value. It needs to be between, oh my goodness, there's no answer here. That's my mistake. Sorry, guys. Ever make a mistake? Happened to me. Okay. So the angle I'm looking for needs to be the one going this direction. Everybody okay with that? So I could do this two ways. I could figure out and do like pi over 2 plus pi over 2 plus pi over 2 plus whatever this piece is. Or I could do 2 pi and then minus what this piece is. right? So that's like saying I'm going all the way to here and then taking back that much. Would give me the same thing. You guys agree with that? Okay. So the thing here is, though, when I take back that part, it's positive. Because I'm subtracting an angle, not like an angle that we built on the unit circle. I'm subtracting like an angle you draw on your piece of paper that is bounded between 0 and 360. I know. But you could do it the other way too. That would still be okay. It doesn't really matter. Either way of thinking about it is okay. So our answer here would be 4.87-ish. And again, we can check this by doing tangent of 4.87. Which is pretty close. Why are we off? Because we rounded. Let's see if we can get that a little closer if I cut out the rounding. So I'm going to add this negative as the same thing as subtracting the positive. And if I do tangent of that, I probably get something that's a bit closer. Yeah. So we're off just because of the rounding. So just kind of keep that in mind if you're going to check. If you're pretty close, that's probably good enough, because if you did any rounding, you're going to lose some accuracy there. But that's much better. Okay. What if I do something like cosine inverse of tangent of 45? Oh, sure, Kendall. You're doing that. We're talking about this one, tangent. Okay. Yes. It's asking it for in this range. Well, 3 pi over 2 is just a number. Right? If I do 3 times pi divided by 2, that's just a number. And 2 pi is just a number. So that's definitely in between those two values. And not every time you're going to be able to give a radian value in terms of pi. Sometimes that's not going to be possible. And this is one of those cases where a decimal is surely very appropriate. You're welcome. That's a good question. Hannah? So the reason I didn't do that, you certainly could have done that, but you would have also had to figure out what that piece is, which would just be like pi over 2 minus 1.41, which would be fine. You could certainly do it that way, and that's not wrong, but it's the same thing as what we've done here. You'd get the same answer either way. So just to illustrate that, if I did pi over 2 minus 1.41, that's this. And then if I add pi over 2 3 times, I get that same 4.87. Okay, so doing it either way is fine. Correct. So what I did was I went all the way around and then took some back versus counting to the spot. Either way of doing it gets you the same answer. So either way of doing it is fine. You're welcome. These are good questions. Again, if we're doing stuff and you're not quite sure on, please stop me and ask questions. I'm sure you're not the only one confused by what's going on. And this is a really detailed course, right? There's a ton of detail involved with trig. And usually the detail makes a lot of sense, but if you're like missed why we did something, like that's a big miss. So like make sure you ask questions if you don't understand why we did something. and I'll certainly take the time and try to re-explain it or whatever we need to make sure that it's clear. Okay? Okay. So, what if I want to do cosine inverse of tangent of 45? Question becomes, should I work from the outside in or from the inside out? There is a right answer here. Inside out. So we're going to start by evaluating tangent of 45. How do I do that? Is 45 degrees a familiar looking angle measure? Yes. Where could I find tangent of 45? On the unit circle. Right? So tangent is y divided by x. So what would tangent of 45 be? 1. So this is going to equal cosine inverse of 1. Now I'm going to go back to my unit circle and I'm going to look for places where the x-coordinate is 1. So it's here at 0. And then 2 pi, I guess, if you wanted to say that. Okay. So notice in this problem, we weren't given a range of values for the angle measure, right? In that case, we're going to assume that it's just the range for cosine inverse that our calculator would use. So if I went back and looked, we said the range for cosine inverse is 0 to pi. Right? So which of these do I want? 0 or 360? I want the 0 degrees. Was that okay? The calculator? And this is, again, we're thinking about it as degrees, 0 to 180, right? Why did I report a degree measure in this problem? Because the problem was in degrees. We had tan of 45 degrees. Because that's the answer. Well, because 360 is not between 0 and 180. So that one's not the one we wanted. And we gave a degree answer because the problem was in degrees rather than radians. Your answer should match whatever you're given, right? We started with 45 degrees in the problem, so our answer should be a degree answer as opposed to a radian answer. Hallie? You should, it's more clear as to why I circled that 0 as opposed to the other 0, which is the 0 radian, is why I put that in there. I wouldn't mark it wrong if you didn't write 0 degrees, but for note's sake, I wouldn't squeeze that in there because maybe it makes it a little bit more clear. Okay. All right. A little notation aside, we use the symbols arctan, arcsine, arccos kind of interchangeably with the symbols sine or tan inverse, sine inverse, and cosine inverse. So you may see that in the homeworks at some point. This is a notation that was much more popular probably like 30 or 40 years ago, and has kind of grown out of fashion. But it still kind of creeps in here or there. But it basically, we can use those two things interchangeably. So remember that there were actually 6 trig functions we defined way back when, right? There's been sine, cosine, and tangent that we've worked with a lot. The other 3 were cosecant, secant, and cotangent. So remember cosecant of x. How was that? Which one was that related to? It was sine. Secant was related to cosine, and cotangent was related to tangent. What? Cotangent? COT? So what I want to do is my calculator doesn't have a cosecant or secant or cotangent inverse command on it. So I need to find a way to rewrite this in terms of sine or cosine or tangent that my calculator does have an inverse button for. Everybody okay with that plan? Okay. So I know that cosecant of x is equal to 1 over sine of x, right? Everybody agree with that? So hopefully we would think that I can just write this as 1 over sine inverse of 2.5, right? Unfortunately, that doesn't work. Let me just demonstrate. We got an error. It says a domain error. Why is that? Well, let's go back and look here. When we talked about this way in the beginning, we said the domain for sine inverse on our calculator is -1 to +1. I just typed in 2.5. That's not in the domain for sine inverse. We've done something wrong. Nice hiccups. You're welcome. So this is not what we want to do. Here's what we do want to do. We're going to do sine inverse of 1 over 2.5. So the reciprocal is applied to this value, not to the whole thing. And this is a radian answer, by the way. let's stop here.